Hello everyone, and welcome back to my channel. Today, I'm going to show you how to build a custom UI application on a Raspberry Pi using LVGL and SquareLine Studio. And in the end, I'll show you how to build and run this E-Bike GUI on a touchscreen display. Let's get started. I have connected my Raspberry Pi to my PC using SSH and created a new, empty directory for our project. We'll be using the LVGL Linux port repository to get started. It already includes drivers for Linux devices in the src directory, so we can jump right in. I'll add the GitHub link in the video description. Let's clone the repository into our project folder. Now, navigate into the LV port Linux directory. Then, fetch the LVGL submodule as well. Next, let's open this directory in VS Code. I've already set up VS Code for remote debugging on the Raspberry Pi using SSH. First, connect to the board, and then open the project folder. Open the lv_conf.h file to select the appropriate drivers and libraries for our build. First, enable LVGL content, and set the color depth to 32-bit for better visual quality. For the graphics driver, I'll use the Linux framebuffer, which allows rendering the UI directly to the Raspberry Pi touchscreen. Let's enable it. Set this to 1. Since I'm using the official Raspberry Pi display, it also supports touch input via evdev drivers, so let's enable it also. Set this to 1. Now, let me show you how to find the screen device. First, let's check the framebuffer device. Open a terminal and run this command. In my case, the output shows dev fb0, since I've only connected one display to the board. Next, let's configure the touch input. Run this command. This lists all the input devices connected to the board. To configure correct touch input, run this command. Sudo ftest. Now, you need to select your touch input device. In my case, I've connected the Raspberry Pi display via the MIPI DSI port, so my input device is event number 4. If you're using a different display, make sure to select the correct event number. Once selected, try touching the screen. You should see input events being triggered and printed in the terminal. Next, navigate to the display backends directory and open the framebuffer driver file. In the initialization of the Linux framebuffer device, make sure to specify the correct device. In my case, it's FB0. You might notice that VS Code doesn't recognize the lv_conf.h file and its predefined. Let's quickly fix that by adding a ccpp properties.json file to configure the include path. This step isn't mandatory, it's just to help VS Code recognize the LVGL project definitions. Now, open the evdev.c file and set the correct input device during initialization. Then save and close the file. Open the main.c file. Set the correct window resolution. In my case, the display resolution is 800 x 480 pixels, so I'll update it accordingly. Let's build the project. I'll be using CMake, but you can also use a make. Actually, before running that, open the CMake lists.txt file. Since we're only using FBDEV and evdev backends, you can remove the others to avoid unnecessary builds. If you're interested in building this with SDL or OpenGL, let me know in the comments, I can make a dedicated video on that. For now, I'll just build the LVGL example application, so I'll leave the target links unchanged. Save the file, and let's build the project. Run this command in the root directory. This sets up an out-of-source build, which is cleaner because it keeps generated files separate from your source code. Go to the build folder and run CMake build. It might take a little time for the first build, so just wait for it to complete. Once it's done, you'll see that the target has been successfully generated. Let's run the target. But before that, we need to stop the desktop service to allow full control of the screen. To do that, run sudo service lightdm stop. This will turn off the desktop interface, and the screen will go dark. Now, run the target, you should see the LVGL demo widgets running perfectly on the touchscreen. However, you might still see the mouse cursor icon on the screen. Let's remove that. Press Ctrl+C to stop the running application. To restart the desktop service again, run sudo service lightdm start. Now, open the evdev.c file again and scroll to the part where the mouse cursor icon is initialized. Comment out this. Actually, not this one. Comment out that section in the input device initialization. Save the file, build the project again, and rerun the target. Now you'll see the application running without the mouse pointer, just the clean GUI on your touchscreen. If the mouse pointer still isn't hidden after commenting out the cursor initialization, it might be due to the mouse driver being enabled in the kernel. In that case, you may need to disable the mouse driver directly in the kernel settings or via the boot configuration. Let's launch SquareLine Studio and create a new E-Bike demo application. Go to the Examples section and select the bike demo project. I'll change the screen resolution to 800 by 480 to match my Raspberry Pi display. You'll notice that the LVGL version here can't be changed. If you remember, the demo widgets use LVGL version 9.3.0, so we'll need to re-download and match the correct version or update UI LVGL version to correct version. For now, just leave the version as it is and create the project. Now, open the project settings. Set the file export path and the UI export path. Change the SquareLine version to 2.0.1 and the LVGL version to 9.2.2. There's no need to change the board, just leave it as desktop. If you're watching this in the future, the versions may have changed, just be sure to match your LVGL version with the one you're building your UI. Apply the changes. Let's run the UI preview. It's a simple two-page layout with some neat animations. Now export the UI files. Open the export directory, you'll see that the UI files have been successfully generated. Open VS Code inside this folder. This makes it easier to copy the files to the Raspberry Pi using the SSH connection. Make sure there's a CMake lists.txt for the UI files. Now, open your Raspberry Pi project directory and create a new folder named UI inside the src directory. Copy all the SquareLine generated UI files into this new UI folder. Open UI.h and give correct path to lvgl.h, then save the file. Open the top-level CMake lists file. Change the executable name to E-Bike. Add the UI subdirectory to the project. Follow these steps. Remove the links to LVGL examples and demos. Instead, link it with the UI source. Save the file and build the project. You'll immediately hit a too few arguments to function error. That's because the LVGL version in your system doesn't match the one used in SquareLine Studio. Let's open the function definition. The error is due to a missing Boolean argument for animation enable. Just add false argument. Save the file and build again. This time the function error has been resolved. If the version of LVGL is different from the one you use in SquareLine Studio, it can cause many errors, so make sure both versions match. Now, you might see a warning that a directory is not found. Close the build and check the CMake lists.txt. The UI source path is incorrect, fix the path. Build again, the warning should be gone now. This happened because in the UI CMake lists, the directory is added as UI. Now we can build the project with our new UI, but we still haven't connected it in the main code. Open main.c, comment out the LVGL demo header, and include the new UI header. In the main function, comment out the demo widget's demo slideshow functions. And then call the new UI initialization function. Save file and build again. The project builds successfully. Head to the bin directory, you'll see a new E-Bike target file has been generated. Let's run the target. There it is. The bike UI is now beautifully rendered on your Raspberry Pi screen. You can now create and integrate any UI designed in SquareLine Studio into your own LVGL project. Thanks so much for watching. I hope this walkthrough helped you build your own custom GUI using LVGL and SquareLine Studio on the Raspberry Pi. In the next video, I'll show you how to create a UI for STM32 using the same tools. So don't forget to like, subscribe, and hit the bell icon to stay updated. See you in the next one.